And you're here in Comp 201 Security Plus. Hey, we're on Chapter 14, Part 2, picking up on Slide 8. Hey, there's 22 slides about resilience through redundancy. That's a hint as to how important redundancy is in cybersecurity and in networks in general. Not only networks, but all kinds of devices. For example, unmanned space probes to Mars and other places have a lot of redundancy because you know what? It's really hard to send a fix-it team out to a probe that's on its way to Mars. You can't do it. So everything that's possible to have a backup device is done on those space probes. And same thing that companies want to do to have high availability, you need redundancy. And here's what I mean by redundancy. For example, if you have a web server, don't just have one, have several. So if one of them goes down, the others pick up the slack. So have multiple devices. We're going to talk about having multiple disk devices too. But let's look at this slide for a sec. So fault tolerance is a concept of dealing with malfunctions and making sure the system doesn't actually go down by having redundancy. So the solution to fault tolerance is to build in redundancy. Duplicate equipment. One goal, it's important to know this measure, mean time to recovery, MTTR. This is a term that's used all across science, actually, not just cybersecurity or computer science. Mean time to recovery is the average amount of time, typically measures in hours or thousands of hours, that it takes a device to recover from a failure. I'm sorry, I was mixing this up with mean time to failure, which is measured often in thousands of an hour. We hope that mean time to recovery isn't measured in thousands of an hour, but a couple hours max, or maybe some number of minutes. So later, we'll be seeing mean time to fail, MTTF, which can be measured in thousands of hours. Okay, so we're planning for redundancy in a variety of different places in our network systems. Endpoints being computers, for example, used by employees or people, other people that are on computers, as opposed to servers, which are used by many, many people. An endpoint computer typically is used for just one person, but a server might have 1,000 people remotely logged into it. So if a server goes down, that could really be a big impact. So that's why we have redundancy in servers. Disks can fail, so you have redundant disks. Networks can fail, so you have some redundancy in networks. And we'll talk about redundancy for power and other things in a few slides. Okay, let's first talk about endpoints. So we're talking about, for example, employees in a company have a computer on their desk. Now, that one user is not as critical as 1,000 users that are on a server, or maybe disks that are on a server, and networks that take care of possibly hundreds or even thousands of employees. But they're still important. We still don't want endpoint computers to go down any more than they have to. Now, we're talking here kind of about hardware fails, but also software can be an issue. Operating systems can fail, particularly when you apply updates to them. So most operating systems have a feature such that you can revert back to an earlier state of the operating system, like before you installed Windows Update. So you can roll back the clock, that is, roll back the version of the updates to the operating system and restore it to an earlier point. Let's see. We'll come back to that at a different time. Servers. Okay, servers. Hey, they play a key role in network infrastructure. And if they go down, it could be a significant business impact. Unless you take precautions like clustering. Have several servers that back up one another. So clustering is when you use several servers, two or more, and they appear as a single unit. For example, if you have 3 web servers, a person logging into your website or accessing your website, doesn't know that you have 3 web servers. All they care about is that you have one working web server. So that fact that it's 3 web servers is invisible to the user browsing that website. Okay. We're going to talk in a minute, next slide, about 2 different kinds of server clusters, asymmetric and symmetric. So let's take a peek at that. So an asymmetric server cluster, now this seems weird to me. See if it seems weird to you. That let's say you had 2 web servers and you were using the asymmetric server cluster model. One of them would be the primary one, which would be being used, and the other one is a standby server. That means that it's doing nothing unless the primary server fails. Doesn't it seem like it would be better if both of them were working all the time? And if one went down, that the other picks up the slack? Well, that is exactly what a symmetric server does. All of them, all the servers do useful work. And if one server fails, the remaining servers take on the failed server's work. Seems like a better utilization of hardware to me. What about to you? And we've studied virtualization in earlier chapters, and this comes into play too. I'm not going to get into details on that. Oh, here's one thing. One thing good about virtual machines is it's pretty easy and quick to copy one virtual machine onto other physical machines. So you can make a copy of a VM virtual machine and launch it on another physical machine. Making a copy is called replication of a virtual machine. This can help in getting started again and having more redundancy by having several virtual machines. And here's a picture of a server cluster. So we have several clients. Let's say these people are browsing the ACM web page. And here is web page server number 1 in the ACM data center. Imagine this is web server number 2 in the ACM data center. One backs up the other on failure. They could have a shared disk so that all the web pages are on disk that's shared by both servers. This isn't necessary. They could each have their own disk. They'd want to keep those disks synchronized so that updates to the web pages are distributed to both servers, or you can share one disk. Let's see. So, by the way, these are called private clusters because both of these are inside the data center. And the fact that you're sharing these, that these are working together, is invisible to the outside world. Let's talk about disks. Disks are really important, obviously. And we're going to talk in some depth about RAID disk, redundant array of inexpensive disks. And we'll talk about storage area networks, too, in a few more slides. But let's right now talk about solid-state drives versus hard disk drives. I'm sure you're all familiar with hard disk drives. Here's how they work. Inside a hard drive is a spinning platter or 2 or 3 spinning platters, spinning pretty fast, like 5,000 to 10,000 RPMs. And there's a magnetic surface on it, on each of those platters, with microscopic magnetic dots that can be magnetized. And there's a read-write head that hovers just above the surface to read and write the data from the hard drive. So these are mechanical devices, spinning platters and moving read-write heads. Compared to how fast the CPU processes stuff, these guys are really slow. So one way to speed that up is the use of solid-state drives. SSDs are somewhat like flash drives. There's no moving parts, and the data persists. So if the power goes down, not a problem. Solid-state drives can maintain that information, just like hard disk drives do. Solid-state drives, the cost has been coming down year by year and over the last 5 or 10 years. So, they are more expensive than hard disk drives, but they're like 20 times faster. So there's some advantages to them in spite of them costing more. And they're more reliable than hard disk drives. Hard disk drives are often the first thing to fail because they are mechanical. Remember I mentioned mean time between failures? So MTBF, typically measured in hours or thousandths of an hour. Mean time between a failure. So typical hard drives would be thousands of hours between failures. Knowing this number, like when you purchase a hard drive, the vendor might tell you the mean time between failure. That can help you determine how many spare hard drives to have on hand when a hard drive fails in your company. Mean time between failures. That's a good test question to ask something about this. Hey, remember I mentioned redundant array of either independent or inexpensive devices? You'll see this both ways. Our book has a redundant array of independent devices. Here's the deal. We're trying to get some redundancy in the hard drive so that if it fails, it doesn't totally fail. What do I mean by that, doesn't totally fail? Here's what I mean. You put multiple hard drives inside one package, and so that if one of those hard drives fails, the other hard drives in that package have all the data they need for you to resume without missing a heartbeat. So we'll study this in a bit more detail of how these work. They're pretty cool. RAID drives are usually implemented through hardware. I guess it could be implemented in software, but as far as I know, they're always, mostly implemented in hardware. And there's several levels of RAID that you have to know for the test. And one of them is RAID 0. Let me just fast forward here. So there's RAID 1, RAID 5, there's RAID 6. Maybe your book doesn't talk about that. Let's start at the beginning here. Right here. So there's a level 0, 1, 2, 3, 4, 5, 6, etc. for disk. The level means the architecture of the hard drive. I'm just going to talk about level 0 on this video, and we'll pick up on the next one. So level 0 is funny because this is the only level that actually doesn't supply any redundancy and thus has no fault tolerance. The advantage to level 0 is performance is improved. And this mechanism of performance improvement is called striping. Let's see, I think there's a picture on the next slide here. Yes, RAID 0. So RAID 0, you'd have multiple disks, and you'd be writing the data to these different disks. So to the outside world, that is to the computer, they look like one disk, but they're actually implemented as 4 physical drives. The reason for this and the advantage of this is that because you have 4 physical drives, you could actually be reading or writing from every one of these 4 drives simultaneously. So potentially the bandwidth, the data bandwidth to and from these drives could be 4 times that of if you just had one disk here. So there's a performance advantage, a bandwidth advantage to having RAID 0, but there's no redundancy advantage. All of the other RAID levels provide redundancy. So if one of the disks fails, the other ones can provide the necessary data and everything works without a problem. I am going to pick up on the next video talking more about RAID devices.